Welcome to our presentation. We are team number 1 and we are going to talk about irrational equations. Irrational equations are also called radical equations because they are affected by a radical sign that in this case is the square root. The process of resolving an irrational equation is to simplify the equation until we only have the rational and the irrational terms. When we have this, we're going to multiply both of them by a square. We make this to eliminate the square root so we can finish our equation. This is the example of an irrational equation. We can see that this is an irrational equation because of the square root that, as we say, is an irrational sign. So, because we don't have any other signs or numbers affecting this equation, we can proceed to multiply both of the terms by a square, as we can see right here in the process. We eliminate the square root by the square, and in the other side, we are going to multiply the 2 by the square, and the result it will be 4. The next step is to separate literals from the numbers, and we make this moving the 14 to the other side in a negative way, and making the difference in this equation, it will give us the result that is minus 10. But now we have to move the 5 to the other side. So because this is multiplying the x, we move this dividing, and the result of this division, it will be minus 2. And that is the final result of this equation.
Particulate use. A series of real problems can be modeled with radical equations. When we encounter a problem where a variable appears inside a radical, we raise both sides to the same power to remove the radical and then solve the variable. Example of the particle use. The dotted line in the drawing above denotes making it easier to see the triangle created by the diagonal length and width. Note that the problem asks the microchip area. To find it, we have to multiply the length, which is 5 mm, by the width, whose length is represented by the variable b. We will use Pythagorean theorem to find the value of b.